Hello everyone, welcome to Knowledge with Satish, and I'm a senior Postgres DBA. Today we cover one of the most important topics. Why does Postgres not use an index even when it exists? Come on, let's see. 13 real scenarios with live demo. Each scenario problem first, then fix. Okay, come on, let's create database setup. I'm just creating one empty table with employee table, name as employees, right? Giving serial primary key, okay, for employee ID. Others are name, email, salary. All these columns are taken for to cover all this almost these scenarios. Okay, let's create one empty table, employees. It is created. Now insert some rows in it around these many 1 lakh. This is the rotational code. I'm inserting some rows in it using generate series as a serial. Okay, for all these things in a empty table. Currently, right? Let's check. I will show you. This is empty. Let's generate some data. Insert inside this table. Yeah, it is inserted 1 lakh. Okay, now I am creating index which is required for cover these scenarios. Email, salary, department, and this is composite index. Okay, let's create. Yeah, created. Remember, after creating index, you need to analyze. I mean, update the statistics of employee table. It is to get exact actual update. Okay. Now coming to the first scenario, data type mismatch. What is when it will occur? Whenever application passes wrong data type to a column, this causes error or force to use sequencer scan. So let's see that scenario. Right. This is the first scenario. Now, see, I'm just adding one more column to this table, existing table employee code to show this alter table adding columns. Okay, with varchar 20 alter. I'm just updating this column with mhm. Employee ID is a serial primary key. Okay, I am updating this employee code numbers with this. Now it is null. Inside it is null. Uh, um, uh, what we are updating here, see null. What we are doing here with the employee ID already we have data in it, right? With the general series. See, using that already existing number of this employee ID, we are converting this is actually varchar only. Okay, we are updating those values to employee code, whatever existing in this employee ID. Okay, let's do it. Okay, it's updated with 1 lakh rows, right? And I am creating index on that column, newly created employee code column. Okay, right now we have index. Remember, after creating index or any vacuum thing, you need to update, analyze the employee table to up to date, right? Now, see, correct approach. Yeah, here we are checking. This is varchar, right? So it will take. We are explaining, analyzing this query where employee code is 100. Okay, what it will do? We have index, right? It is doing index scan. Correct data type it is taken here. So whenever we are giving varchar as the integer, see number, it will not, it will throw error because data type we are giving wrongly. Operation does not. We are giving integer here. So this is wrong operation, right? Now we can use this employee code with different data type and see, okay, with integer values. That's why whenever you use any query, we need to specifically use the same data type in the query as well. We are giving to employee code for it is varchar, but we are mentioning here um, we need to always use the these quotations, right? Index, then it will use perfectly. So wrong data type causes this complete failures. Application must always pass correct data type. Now, casting the column in where condition. See, it is not a integer, but we are casting here. Let's see what it will do. See, it is doing sequencer scan because here our data type is varchar, but we are mentioning integer. See, it is doing sequencer scan in this. What is the fix in it? We need to create a index as like same this. We are creating index same as like this, right? Now check with that value. Since we have index with that same casting, whenever casting is unavailable, create a function based on index matching the exact cast. Always use the correct data types. Never cast columns in where clause. If casting needed, create function based index as like this I have created here. So let's check the plan now. Earlier it is sequencer scan, right? See, index scan. Understood? This is whenever a data type mismatch will happen, index will not use even though if we have index. And this is the first scenario. Let's go to the second scenario. Negation conditions. Okay, second scenario. Now, what here sequences can salary. So here, 1 minute. Negation means not equal using or greater than or less than written too many rows. Postgres always prefers sequencer scan only. So let's check. See here, see not equal and all we call as a negation. I am checking, explain, analyze of this query plan. Let's see while using negation in the query what it does. Even though we have index on salary, right? It's almost written see one. 1 lakh almost, right? Now what I will do, hmm, here, yeah, index scan. It is fetch rows return. Select only select I am doing. Yeah, index scan few rows. Let's check this without negation. Doing index scan. See, that is the different here. Here using negation sequencer scan it is doing. You using without using that in the query it is doing index scan. Now what we do to check the both the scenarios, I'm adding a highly selective filter like see I'm using two conditions here. Forces the index usage first and then check the negation condition later. I am giving two conditions. So avoid negation alone on large tables. Always add selective filter to reduce the result set. See here, even though if I'm using negation, right? But here we are selecting, see, employee ID means 100. We at the same time email 100 we are selecting. So filter is less. Less row selected, it will use index scan here. Index scan. If we are selecting too many rows with negation for higher table, it will do sequencer scan only. You understood? This is the difference. Always avoid these kind of negations and all for larger tables. Understood? Now go for next scenario. Functions. When we use any functions on the column, like see, applying function like upper or lower on indexed column breaks index usage. Postgres cannot use regular index in this scenario. See, we are using functions on indexed column. See the plan. Sequencer scan it is doing. Right? Postgres must apply up to every row in table. Cannot use index because index stores original values. See, now I am creating function based index. And see, to for the fixing for this issue, I am creating function based index. Already we have used this function. I am creating the same index whatever we are using in the query, right? Remember after index always run this to up to date. Now check the plan of the same above what we have checked. We have index now with function, so it will do the index scan. See, before it is doing sequential scan because we are using function in the query. So after we creating index on that function, we can use that index accordingly. So index must exactly match the function used in query. Upper in index, upper in query, perfect match. So never apply functions on indexed columns. Create function based index and match the exact function in the query, then we can avoid a sequential scan, right? Now coming to the fourth scenario, this is very interesting. Now applying max operations on a column in where clause prevent index usage same as the functions on column. Understood? I will show you with examples. So here see Uh, Postgres here calculates salary times into 2 for every row, right? This is this is like this. Uh, it is touching mathematics is touching with indexer column. So every time it should multiply with greater than every column here. So let's check this already. Okay. Sequencer scan. See. So so cannot use index because index stores original salary values because of it is touching mathematician on this column row. So what we can do for fixing this, um, even after we are removing max from the column, let's see max from the column. Okay, greater than 5. Yeah. If conditions returns 50,000 rows, that is almost 50% of existing, right? Planner still prefers sequencer scan. It's cheaper, not because it's not selective enough, right? Even though if here we don't have any mathematicians, but it is doing more than 50,000, so it will go for sequencer scan only. Now fix what we are fixing here. I will show you. This is see same thing here. Selective is less. Okay, right. Mathematics same thing. Same thing. It will do index scan because here selective rows are less. So optimizer thing compared to sequencer scan, index scan is cheaper and it will go for index scan. So two lessons here. First one, never apply max on columns. Second one, condition must be selective enough to benefit from index. Understood? Never apply max. Condition must. Yeah. Okay. Now coming to next scenario. Composite index, wrong order. What is composite index? It is nothing but multiple columns. In the index, we are having multiple columns. So must include the first column in where clause. This is a called left prefix rule. We should compulsory use that rule whenever if we use any composite index. Okay, let's check with first our composite index. Yeah, max is done. Index. That one. Okay, we have composite index on these two column. Department is the first column. Okay, now let's check. This is wrongly written. Plan for department we given first, salary we given second. It will do index scan, right? This is done. Without first column, we are doing only second column including for this salary. It will do sequencer scan. Understood? Here, without a department in where clause, PostgreSQL cannot use composite index efficiently. It is 14 times slower compared to this output. You see? So, what we can do it right now. Left prefix rule here we need to apply. Always include first column of the composite index in where clause. See, first column I have included in the index scan. Understood the difference between in composite index if we didn't added that first one, right? I hope you people, all people got it. Coming to the next scenario, right? Now R condition. If we are using R conditions, we have two rules. All columns, whichever columns in between R must have index for both the column R, and result set must be small enough. You remember this 2 points, okay? Now we index. We are dropping one index on gender, right? And let's see. We have index already earlier. Having index means see. Okay, I am dropping index. Okay, dropping index. Let's say this first one. See, sequences can, as we have seen here. Now, gender has no index. It failed. Both both index but large set. Second one. What I am doing? Again, I am recreating that index, which are I deleted or dropped earlier, and I am analyzing it. And let's see. Sequencer scan only here. Why it is doing. Gender M means gender male and female is off 50,000 male, 50,000 female. So almost for like I mean, what even if you are selecting more than enough, 58% of the table it is written means optimizer will assume that instead of scanning all and fetching heavy rows, what it will think, sequencer scan is cheaper compared to index scan. So it will choose sequencer scan only, right? What we do in this scenario then, yeah, 58% it is completed step 3. Now, uh, see R condition, both we have columns. I'm just showing the example here. Bitmap. See bitmap index scan. It is index scan it is doing. R condition both having index with lesser values. That's why it is went to index scan. Only two rows, right? So how to fix this issue? Whenever you are using R condition, try to avoid and or else if you are having R condition must ensure it select to less rows and both the columns should have index, or you need to mention union all to avoid that scenario. Sorry, I need to explain and let's see index can it is doing before. Understood? So union all splits are into two separate queries. Each query uses its own index, better performance compared to R. R rules all columns needs indexes. Same results uses indexes. Use union all for larger results. Got it? And this is the R scenario. Now coming to what else other scenario index will not use. This is very common thing. Everybody knows. But we need to ensure this in production it never, but we should never play with this parameter. It's very dangerous. Never touch these things in production. Anyway, by default, those are wrong. So whenever Postgres has setting to enable or disabling indexing usage, but accidentally disable index causes all queries to be sequencer scan only. If we are disable index means, see, I am disabling index now, right? It's very dangerous in production, you know. We should be very cautious. Okay, now let's see. This having index sequences can see. Index is disabled, that's why. You understood? Now always verify these settings if query suddenly became slow in production. Okay, now enable it, enable back, enable back. It will do index scan. Understood? So check show enable index scan if queries suddenly slow down or never disable indexes in production. Keep in mind. Now coming to the next scenario, which case index will not use. Mhm. So let's break down. Now we are going to checking for invalid index. So invalid index exists in catalog but is not used by planner. Happens when creating index concurrently and fails due to some duplicates or crash or any deployments, you know, or any blocking. So many scenarios. Let's let me show you invalid index scenario. I am creating one table for showing this invalid index, right? Table created. I am inserting some rows inside the table for this column employee code, right? 5 rows was inserted and generating 10,000 rows. You both are same. Okay, now I am creating Unix index. See here, columns are same. Unix index I am creating concurrently means online. Unix index. It should fail because we have duplicate values in it of e20. So duplicate values means index will not, it will throw the error, but it will create the index with the status of invalid. Let me verify with the query. See, false. This that nothing but invalid. So here, what we are doing now, employee ID. It will do sequential scan only because it will not pick up the index because that is invalid already. Understood? Now what I am doing, I am deleting duplicate value from this invalid index table so that we can, I have, okay, I have, okay, drop in the 1 minute. Anyway, let me check whether it is drop. I think it is drop. Drop, yeah. Let me create one. It's okay. Yeah. Now, what I am doing from this is I think already done. Yeah, already done. Dropping Duplicate values was dropped. I am dropping existing index and recreating the index. Now duplicate values are not there. See, index was created successfully. Now, after monitoring invalid index, now see the plan. It is using index scan. Valid index, now it is used. So we always monitor invalid index, select from PG index, no, fix by removing duplicates value, and we need to reindex it. Understood? This is one scenario. If index is invalid means. Now go to the next scenario. Stale statistics. This is very interesting. Now I am creating a table with the stale statistic demo for showing you ID, primary key, department, and salary. I'm creating one query, one table, and I'm inserting some values in it, right? Postgres uses statistics to estimate the row count. A stale statistics causes planner to make the wrong decision and choose the wrong execution plan always, right? So here I have inserted. Now create an index on department and make analyze of the table. Now insert new department without analyze. Okay. We created index and department, right? So we are inserting before after we inserted some rows, we have created and analyzed. Now see, I am inserting 1 lakh on department. Okay, right? Inserted. Now let's check the plan for this very clearly. Where department is management. Under management, we have inserted this. So let's check for management. See here the estimated rows is 1,967. Understood? Now planner thinks, okay, one rows. I didn't analyze this. Mhm. Okay, let's check. Okay, analyze it. Let's analyze it. It is showing something 1,96. Just analyze and check the same thing. 1 lakh. Now it is giving the current exact. Okay, we have inserted so many rows. That's why. Insert new department. You see. Now this is the correct one. Earlier one is not exactly one. For example, let's insert only two. Now this is the correct count. Earlier one is not the correct count. This is after analyzing, it will show the exactly. Mm-hmm. Okay. Hopefully you understand. What I am going to tell you without we are doing analyze on the table after we update any heavy load, it will not give the right rows here. So plan may change. Understood? We should always ensure after analyze, planner correctly estimates the exact rows and make the right decision. Always run analyze after any large data loads. Understood? Or configure auto vacuum properly. Check pgstat user tables for last analyzed timestamp. Now, one more scenario I can't show you. Low cardinality. That nothing but cardinality means number of unique values in a column. Unique values. Low cardinality means very few unique values like gender with only male or female, Y index does not help for low cardinality means gender may M written 50,000, 50% of the table. Postgres thinks fetching 50,000 via index scan is more expensive than sequencer scan. So it will pick up sequencer scan only. Instead of the heavy updated the rows and all. Here Postgres 17 I'm using. It's very smart. Even with low cardinality column, it may still use index. I have example. It is still using index scan only. So do not index on gender, status, active, inactive, Boolean columns. Do index or email, the phone number, high cardinality columns. Low cardinality columns, waste of index space. Focus index on high cardinality columns only. Understood? Now let's go to the next scenario. Collation. Collation. What is collation? It defines rules for comparing and sorting the text. Index with one collation and query with a different collation cannot use that index properly. Let's show you the demo. See here we are using collation of this type. Okay. We are creating one table with this collation and we are inserting some values in it. Okay. One lakh. And I'm creating index on it. Okay. And after index always remember analyze. Now step one. With the same collection, I'm checking the plan. See index scan it is doing. Now I'll go for different collation. Here collation C different type and check it will do sequencer scan C. Understood? It should match. Index uses ENUS rules, but query uses C collision rules. Comparison rules are different, so index cannot be used in this scenario. Always be consistent with collation. Common issues in multilingual applications matches collection in the index and queries. Now coming to the next scenario, null. Now I am creating what is null. Null comparison with soft delete pattern. Most rows have deleted timestamp. We know only few active rows we have null. Without partial index, it scans entire table. Let me show you the demo. Let's create one temporary table for cross verifying this and insert some rows. Okay, 10,000 and insert some more active employees 20. Okay. Here without partial index is null and checking even though we having index it is doing sequential scan because here uh, it scans all this 10,000 two rows see to find 20 active. It is entire checking. So sequential scan it is cheaper for Postgres optimizer, so it will choose the sequential scan only. It depends upon the scenario. Now I am creating Index, you know, earlier without index, Postgres can. Here we are having 1 minute created table inserted. We don't have index as of now. So without index, Postgres scans entire all the row to find the 20 active records. In production with millions of rows, that kills performance. So now I'm creating partial index for null. Same whatever in the query we are used condition, that condition we are applying in the index is nothing but partial index. I'm creating partial index. This is the fix for this. So after index creation, analyze, we must do on the table, right? So I'm checking the plan now with the same plan, whatever plan earlier I have cross-verified in step 1, same plan I'm choosing now. It should do now index scan. See, understood? Partial index contains only 20 active rows. Instead of scanning all 10,020, it finds only 20 instantly. This is the power of partial index for null. Soft deletion with partial index is most powerful, the PostgreSQL pattern. Creating index with where condition with having null improve active records queries 100% more. Okay, understood now. Partial index means what? With beneficial for in null condition to avoid a sequences scan. Now partial index mismatch scenario. Now I want to create a table. What is partial index? It covers only rows matching specific where condition. Query must include same condition to use the partial index. That's it. Whichever in the query, the where condition, whatever it is there, if we creating that conditioned with the index, that is called partial index. I have created a table and inserting some rows in it. 1 lakh rows I have inserted, and I am creating index status is active with condition. So always remember after index, analyze. We must. Okay, now matching condition. See here. This is wrong. Here, query includes where status equal actives, which matches our patch that our partial index. It's Postgres is just very fast. Let's cross verify index scan. Okay, condition matches. That's why it is doing index scan. Now non-matching condition. What condition we have created in index? Status is active. So status is active means index scan, and status is inactive means it will do sequential scan. See, that's the difference. You know, partial index must match query condition exactly. Used for active records, recent date, smaller index, faster maintenance. So these are all the 13 scenarios what I have covered where Postgres does not use an index. From data type mismatch to partial index mismatch, now you know all the reasons and fixes. If you found this video helpful, please like and share and subscribe to Knowledge with Satish. And also I have published some Postgres, Oracle, MS SQL Server, AWS Server interview guides on Gumroad and links in the description. These guides will help you crack senior database interviews. You can also book one-to-one mentoring section with me on TopMate, the link in description. Thank you for watching. See you in the next video.